Hi, welcome to this video. Today we will discuss the one of the most confusing concept that what if this cylinder or is rotating about its axis of rotation, then why we are calling the force of static friction exerted on it, is it not moving? This is the most confusing topic and concept that came to the mind of the students. So today not only we will understand this, but also we will derive an expression of the force of friction, right? So this is from the A.4 rigid body mechanics of IP physics syllabus for HL. So why do we call it rolling without slipping, right? So first of all, let me define you that what is a meaning of the rolling without slipping. Actually, it means that the pure rolling motion. So pure rolling motion is what kind of motion? It is a motion in which an object not only rolls, right? An object rolls as well as translates, as well as move in a straight line, such that its point of contact, point of contact has a no velocity relative to the surface. This is a kindly stick to the video because I will explain you why does this happen. Its point of contact has no velocity with respect to surface. Okay, so dear students, let us see this diagram to understand. At this point, this is a point of contact, right? At this point of contact, the velocity relative to the inclined surface is zero, whereas this is a center, right? And this is a radius. So we can also call it this is a center of mass. So the velocity of the center of mass of this object is VCM, can I say? And this is equals to R omega, which is written in our syllabus in curriculum, right? Now, what if I take this distance, this point? So this distance is 2R. So hence its velocity will be 2R omega. Okay. But the velocity of the point of contact is zero. Why? Because we are calling this topic rolling without slipping. So where it could slip, it can slip in this direction. So when it will try to slip, so the force of friction will be exerted in the opposite of direction. And this is, dear students, the force of static friction. Why we are calling it static friction? Because this is that necessary force which is keeping this object at rest at that point of contact. So it is avoiding any slipping or any skidding of this object. So dear students, this is the static friction. It's not a kinetic friction or dynamic friction. Then what kind of rolling motion that we can say, uh, the rolling with slipping? So one of the example is, let's say if this is a road and there is the car is moving over the road, right? And since the car has exceeded its speed limit, so what will happen? The car will move along the tangent. So its wheels are rotating as well as this car is skidding as well. So when it will skid, so just imagine if this is a wheel, right? So that point of contact is sliding as well as rotating, right? So in that case, we say there is a dynamic force of friction exerted. So today we will discuss about the static force of friction and we will drive its equation. So how many forces are exerted on it? So obviously the one force will be the exerted along the perpendicular to the surface, that we can say the normal force, and the one force will be exerted vertically downward, that would be equals to the weight of the cylinder, and the force that is necessary to rotate this, okay, to roll it, is the force of friction. And this is the static friction I had already explained you. Now the one mistake that student frequently do, kindly don't make that mistake. The student put this equation, okay, they say that the force of friction must be equals to mu fn, right? So it is not, okay, because it will be in the case of the dynamic friction. So As I explained you that this is not a dynamic friction which is applied on the cylinder or any rotating object. This is a static friction. So we have to apply not only the torque concept but also the Newton laws of motion. So let us start with the Newton law of motion. So Newton's second law, what does it that say? So F net is equals to ma, right? Let's write peak ma. Okay, now, what is the resultant force? So, dear students, if I express the cylinder with this point, so you know that the one force will be exerted vertically downward, that must be equals to the weight mg. The one force is applied perpendicular to the surface because this is a y-axis. Okay, this shows us the perpendicular to the surface, so this should be the normal force. Okay, now the force of friction is applied in the negative x direction, so I'm going to show you in this one. Okay, because the force of friction is that necessary force which is producing torque. Okay, the two forces are not producing torque, because just imagine in this diagram, if I say this is your pivot point, this is your pivot point. Okay, so the weight force and the normal force are both passing from this pivot point, so those both are not producing any torque. So which force is producing torque? That is a force of friction, and it has a distance r. You can say it's lever arm or it's moment arm, whatever you call it, you are convenient with, you can use that. So anyways, we if you make a components of that, okay, so this is a free body diagram, this was a theta. If we make a components of this, so it will be mg cos of theta, and this will be equals to mg sine of theta. So mg sine theta is more than the force of friction. It should be, because it is accelerating down. Okay, and remember one thing, that if this is a surface and this is the object that is rotating, either it's a sphere or a cylinder or a disk, whatever that is, its acceleration of the center of mass will be also equals to r alpha, and the velocity is equals to r omega. This all happens when the sphere or any object rolls without slipping. I hope you understand. Now, so we were talking about the Newton's second law, and I told you, since it's accelerating down, right? So that's why the mg sine theta must be more than the force of static friction. And why it is static friction? I hope you understand, right? So this is, so we can say mg sine theta. Okay, or we can call it, this is our first equation. Now, since we have acceleration unknown, that's why we need another equation. Okay, so that we can combine them to find out the force of friction. So dear students, this is that constant force of friction, right? Since it's a constant force of friction, and I told you it's a static force of friction, it will produce a constant angular acceleration, because the torque that will be produced due to this will produce a constant angular acceleration. So this is a center, this is a distance r, right? So the torque produced by this will be equals to r times force of friction, and the angular version is, is I alpha, right? Now, so r times force of friction is equals to, now this is a I for it, you will be given the value of I, because that is a different for the different geometrical shapes. So if it is cylinder, so it would be 1 over 2 mr square. Okay, if it would be sphere, then it would be 2 by 5 mr square, but you don't need to remember this, it will be given provided in the question. So right now I'm just using this value because we want to simplify the expression till the last step. Okay, so this is okay. Now at this point, I already explained you that we can r- write acceleration equals to r alpha. So what will be the alpha equals to? That will be equals to a over r. So we will write here a over r. So you see that this r and this r is cancelled out. So the 1r on the right hand side and the 1r on the left hand side, they both can be cancelled out as well. So finally, the force of friction in terms of linear acceleration or the translational acceleration, we got this thing is 1 over 2 times mass times translational acceleration. Okay. Now, because we want to drive an equation of the static force of friction, so we should eliminate this acceleration. Okay. So why not if we multiply 2 on both sides and get an expression of acceleration? So that will be equals to over m. So dear students, now we are going to substitute the value of acceleration in this equation to get a force of friction. Okay. Yes. So what it will become? Mg sine theta minus force of static friction is equals to m into 2 times force of static friction divided by m. So it is cancelled out, and mg sine theta, you can add the force of friction on both sides, so it will be 3 times force of friction, right? And finally you can see that force of friction, as I already told you, I have shown you in a free body diagram that this force should be more than the force of friction, but how many times it is less, this final equation is telling us everything with crystal clear, that it is 1/3 of mg sine theta. Now, dear students, I told you that this depends on the geometrical shape. If this will be the rod, or if this will be a sphere or a disc, it will be the different values. So you will get a different force of friction, okay, comparison to the mg sine theta. So this is how we calculate the force of friction. Kindly never do a mistake of using force of friction mu mg sine theta. No, it is always used when the object is sliding or skidding as well. Our topic of today's discussion was without slipping. That's why you have to go through this process. Okay.